Good morning to all. My name is Dr. Guglot Erna, working as an assistant professor, Department of ECE in PACE Institute of Technology Sciences, Ongole. Currently, I am teaching the subject. Course name is VLSI Design. In that topic, I selected ASIC Design from RTL to GDSII. So RTL means here register transfer level to graphical data system information interchanging also that here. Then I will go to the next topic here. So here are the aim of the sessions also that here. What are the career opportunities in VLSI design also? So nowadays the career opportunities are huge in VLSI. Then after that I will explain about that MOS operations. So MOS means here metal oxide semiconductors, and also coming to the what is the next topic also, FPGA and ASIC implementations also that here. And after that also what are the roadmap needing to the ASIC also, what are the skills are required to enter into the ASIC field also that here. Then how to the IC fabrications, next topic also that here. And also here then my outcome also depends upon the what are the objects of the VLSI designs here. So nowadays the VLSI design is very crucial role to design the various devices also that here, like a smart mobiles, embedded systems, and also aeronautical space, in also ISRO also different areas are using in the VLSI also that here. Then they are the high performance processor also can design. That is possible by the only VLSIs. In VLSI, actually VLSIs are the classified here two types here. Here also I will classified as two types here. I will show that. Then one is also front end and second end, and second also back end. The front end and back end, so front end gives the you are writing the coding also that here, SDL coding, writing the SDL coding also, and back end also here also we are after the synthesis, you are entering into the backend tool also that's here. Like also here the floor planning, and also next also here also placement, routing. They are the backend tools also that here. And next I will go to the next slide also that here. These are the career opportunity in VLSI domain. So here also nowadays VLSI course offering a more career opportunity in areas domain also that here, because here also first domain also architecture also that here. So architecture means you are designing the any architecture for any digital system or analog system also, or any SOC also that here, but you have to create the architecture. For that architecture consists of the input and output also that here. And coming to the SOC here, SOC is also stand for system on chip. It is a interconnecting of the number of blocks also that here. So interconnecting of the number of blocks like a digital or like a smart mobile also, smart mobiles. And coming to the next digital IP here also here. IP means here intellectual property. It is intellectual property will be gives the correctness of the result also that's here. And main is also what is the next domain also, power is there here. So power is very important in VLSI. The power here also power, you can reduce the power with respect to of the different technology also that's here, like a MOSFET and like a any flow charts you can take and you can reduce the power also that's here. And security system also you have to need also that here, like encryption, decryptions, AVS standards. You can take those concepts. You can give the security system also here. Coming to the next IP also, that is also intellectual property. The same intellectual property you can use it into the digital designer also here. So digital designer means also, especially this is also digital designer STL subject. Switching design logic system also that here. STLD or DSD also that here, digital system design. And next one also intellectual property verifications. Nowadays verification is also very important to verify the functionality of the our design, because of you are creating the number of architectures also here. For that I am number of architecture, it consists of the number of inputs also that here. So number of inputs also that here. Then only you can verify by using of the IP verification engineers also that here. So here then after that you come to the analog design also that here. So analog design also here you are using the continuous signals, and here also continuous signals also. The continuous signals will be vary with respect to time also that here. Sinusoidal signals, square signals, there are signals also needed here. And next one also here is AMS also there. So here also analog mixed signal also needed also here, that it is a mixing of the digital signal and analog signal. The next step also that here, the next domain also that here, analog signal and mixed signals you can verify the by using of the verification engineers also. That is also here system Verilog. So nowadays here system Verilog is also very, very important also that here. The system Verilog is also very, very important for the writing of the coding of that here. So without here also verification engineers so doing that verification also that here, verification. For example, we are designing a top model code also that here. So top model code also, top model code for half adder. For half adder, like you can write also here in you can write the coding for only in Verilog also that's here. So Verilog means here the how to write the top model code in Verilog means also that here I will design the architecture also that here first of all. So here architecture will be described the, so what is the input, what is the output also that here. Here also input A and B, and output also sum and also C out also. These are the sum and C out is also output also that's here. So like that also you are designing the top model and verification also verification. Coming to the next also that here also SOC lead also that here. So SOC means system on chip is also very, very important role in the VLSI system also that here, because it consists of the number of blocks, it consists of the number of functional also that here, it consists of the number of devices also that here, number of interfacing also that here. That is also is a very important. Without SOC, the Apple cannot be run also that here. And presently, the Apple company design the SOC leading also that here, and also SOC design of that here. Because of nowadays we have the configuration laptop is available also. High configuration laptops are available in market also that here. Because of i7, i9 also that here. The processor will be differ also that here. Previously and present also that here. The previously and present depends upon the SOC also that here. The present we are looking for the SOC also that here. After that they are designing the number of blocks or number of functionals. Then they go to the verification engineers of that here. So verification engineers of that here. And then after that emulation is also one of the complexity of the design functionality. It's described by the emulation also that here. So then after that, then you are sending to the TB architecture also that here. TB means a test bench architecture also that here. After that also, then you are this part will be is also front end engineers also doing here also. So they are the career opportunities here. Here use career opportunity in the VLSI domain also that's here. And coming to the next physical implementation. Actually, physical implementation PD is calling also here. You're calling like a PD, physical design also that here. The physical design classified the floor planning and also placement, routing, DRS means design rule check also that here. So design rule check and LVSS also that here. Layout versus schematic also that here. So these are the things also the PD. Including of the PD, one more also DFT engineers also needed here. So DFT so then also there are how many patterns are required, how many patterns are the error free, and those error will be avoided by the DFT engineers also that's here. So coming to the verification engineers also that here. So again, verification engineer will be verify all the result also that here. So then after the verification engineer to send the test engineers also that here. So then after that also CAD also. CAD means also here the CAD stand for the computer aided design also that here. They are the modeling, packaging, library design also that here. Here so modeling means they are the fabrications units also that here. Because of you need the wafer fabrications also. Packaging means it interconnecting of the number of node to a number of nodes, like a devices, one device to another device. It integrating more number of ICs also that here, or integrating more number of the chips also that here. That is a package also that here. So after that also you have to then you can program management. You can designing of the ICs. You can manage the program also that here, and this is also a domain leads also that here. So which domain will be better also, either it is analog or digital or AMS domain also that here. Because of nowadays without mixing of signal we cannot be use the ICs also that here. For example, in mobile also that here, in mobile is also you need the two signals also that here. One is the digital signal, one is the analog signal also that here. You are continuously speaking with analog signals. Then this analog signal convert into the digital signals also. That is also ADC also, analog to digital converter also. You have to need also that here. So they are the opportunities here. The nowadays huge opportunity to enter in the VLSI field also that here. And then next then by 2028 our India will be creating the 3 fabrication unit in a different location in India also that here. So coming to the next, they are the record here also that here. Mass operation will be there also that here. Because of then this is also very, very important, this one. Because of according the Moore's law, then transistor will be increasing also that here. So everybody knows or as a AC student, the every 1.5 year the transistor count will be increasing also that here. So because of coming to here also, SSI is also small scale integration, MSI also medium scale integrations. The range of the transistor 10 to 500 also that here. Coming to the LSI, large scale integration also that here of 500 to 20,000 20,000 transistors also required here also. So coming to the VLSI, you have to need the about 10 lakhs transistor required also here. So according this also, because of Morse, according the Morse, you can increase the number of transistor like billions of transistor, trillions of transistor in the chip also that here, or in the SOC also that here. So SOC is also very, very important role. Now SOC not consist of one block also. SOC also interfacing of the number of interfacing peripherals also that here. That's why. So then here also mass transfer also needed here, because of already you know that BJT. So compared to BJT, mass is very, very important here. So mass gives the more advantage, stability, and package density will be more also that here. So package density also more to integrating the number of transistors also here. Actually, mass transistor operates in the 3 regions also that here. First region also here also. First region is also 3 cutoff region. So what is the cutoff region means also here that so cutoff region means also according the VGS gate to source voltage less than the threshold voltage, there is a cutoff. There is no flow of the current also here. There is no flow of the current. Then coming to the next linear or non-saturation region, this is a weak inversion and drain also that here, because of VGS greater than VT. But what is the condition here also that here? So that is the condition also here. VDS less than VGS minus VT. According that condition, then we are not getting the perfect, not getting the constant current also that here. So coming to here also, this is also saturation region. So this region will be give the constant current region also here. That is also according the VDS greater than VGS by reliability, and you are getting the output current also very constantly. So coming to here also, FPGA ASIC implementation flow also that here. So for example, you can design any architecture, any block also that here. You can take analog also that here. Because of most of the analog design will be possible by using of the FPGA and ASIC also that here. So and also then also that here also first of all these are the flow. So you can I will explain the one by one flows that here. So there is also specification here also. The specification means also I can take the here three inputs here. So three input. This is also one of the architecture here. So this is also one of the architecture. This architecture consists of the three inputs here, A, B, C, and Pn is also output also that's here. So according that I draw the functional truth table here also. So truth table also that's here. Then here also can by reduce the functionality of the truth table by using of the K map also that's here. By using of the K map also that's here. So they are the things also. And but how to write this function by using of the .v file or .verilog file also that's here. So here actually in VLSI you have the two languages is the major languages to writing a any programming language in also digital or analog also that here here also that is also Verilog SDL. You can introduce the Verilog SDL here also that here. So after writing a code for this function for this block after that you go to the functional design also that here. So functional design, what is the functional design means verify the functionality of the your input also that's here or your output also that's here. So what you have to give an architecture, verify the functionality also that's here. Either it is correct or not also that's here. So by using of the functional design also. So after that functional design, then you have to you are writing the code. No, what are the code writing in the into the Verilog? That Verilog will be converted into the netlist. That Verilog code will be converted into the netlist also. Netlist also that's here. So that is also here synthesis also. The netlist represent in the form of the gates or some IOB input output pads also that's here and buffering also that's here. So after that also technology mapping. So what technology you have to need also that's here. Because of technology mapping, so 180 nanometer or 5 nanometers also, 180 micrometers also that's here. You have to need the technology. That is depends upon the tool. Because of tools are the available in our VLSI also that's here. This will be this flow will be done by the Vivado or Vivado, Xilinx Vivado or also Xilinx also that here, or also model sim also that here, or Costa sim also I can use it also that's here. So to get the output of the result or simulation result also. After that also technology mapping, then you can place and routing also that here. Because of place and routing, you can minimize the logic gates. Minimize the logic gates sizes, and you can maintain the place, and you have to connect the wiring between the one gate to another gate. That is a routing also that here. So these are the things also that here, and after that here verification is needed also here. So verification after that you can minimize and you can reduce the area of the all gates on the die also that here. Then verification you are going to that also. So verification also once again you can check it also that's here. Either it is a mapping or not mapping. So according our specification, you are getting the output or not getting the output also. Then you have to check the verification also. Verification also that here. Then you can go to the fabrication here also. So fabrication means also here you can fabricate in by using of the ASIC flow or by using of the here FPGA flows that here. So FPGA means also if you have the board like a Vertex, Spartan 3, Spartan 6 also, Jet board, this program will be dumped into the FPGA also. That's it. I will show the how to dump the program into the FPGA in next slide also that's here. These are the FPGA dumped into the board also that's here. So here writing the code also that's here. Functional specification already written also. You can write, you can take any examples, comparator examples or full adder, half adder example. You can take also that here, and also here you can dump it into the, you can write the program by using of the SDL language, Verilog language. You can write it also. After that you can simulate the that Verilog comparator program also that's here. Then you can get the output also that's here. Waveform will be you get correctness of the waveform also. Then that also you can convert that also. After that come into the synthesis also that's here. The synthesis which describe the which convert the RTL to netlist also that here. After that place and routing. After this the place and routing completed, then dump into the board also that's here. That is the download what are the codes are already available, you can dump it into the board also, that's here, like a jet board, and also like a Spartan board also, that's here. STA means here static timing analysis. This is a very important here. STA is also hold time, arrival time also already studied in the sequential circuits also. Because without sequential circuits, you cannot design the perfect devices also, that here. Here coming to here also, next one is ASIC. ASIC means here, ASIC stands for application specific integrated circuit also, that here. So to, for example, you are enter into the ASIC field also, like a ASIC means class gives the one front end and back end also, that here. So here also this is a front end needed also, that here. You can need the some fundamentals, you have need the some fundamentals to enter in the ASIC field as a front end engineers also. You have to need the some programming skills, verification skills, using the Verilog and VSTL, and some with some projects also. You can do the projects like a traffic light controller, a car parking also, that's here. And you can UART also, you can write the coding for that also. After that, you also advanced verification skills also needed along with to enter in the ASIC road also, that's here. And to become an expert, you need the some UVM concept here. So UVM stands for universal verification methodology also, that's here. And they are the product. This side, this is clearly given that how to design the one of the product also, that's here. For example, previously just now I described about the 8-bit comparator also here. So what are the 8-bit comparators means also? 8-bit comparators means also A and B. So A and B is also here also. Then here also. So here comparator is there here. So I will write the one of the 8-bit comparator here. 8-bit here also 8-bit comparator. Here also write the coding here. A module. What is the module name also? 8-bit comparator. Here also, then first I will draw here also. Here input is there here. Here also input is also A and B. A and B also here. Output also here also 3 is there here. So here less than, and here also greater than, and also here equal is there here. So they are the architecture specification here. This is the architecture specification, and then you can write the coding here also. What are the inputs here also? A comma B comma, and output also here. I will give the in short form also, that's here. LT. LT is also less than, and GT also here the greater than here. GT also because Verilog not accepting the higher letter also here. So only accept the upper letter not accepted by the Verilog. That's why you can write here also only. So only write the GT right here. Is a lower letter also only accepted, and this is also equal here. Equal right here. This is a equal also. LT and GT and also equal. They are the port declaration here. So what are the port here also? Input port, output port declaration. And now we can write also what is the input and also what is the input here also? A comma B is also input here. A comma B also input. So what is the output here also? Here also, and output also you can take also output here great LT comma and GT comma and equal is the semicolon also, that here. Then write the code also here also. Here output is stored in the register also, no, register need also. You can read the you can need the register here to store the value also. Rig you can write also rig, because rig also considered as the output also, that here. LT, GT and equal is there also, that here. Then you can write the syntax here also, that here. Either you can write the program in the data flow, or either you can write the program in the behavioral level, either you can write the program in the 6 level modeling, because of in Verilog gives the Verilog provides the four modeling scale also that here. So okay, so that's why you can write this they are the product design flows that here. Here you can see that according the market requirement here. Here also nowadays the every engineers also, every R&D, every high computing every customers they are expecting the high computing devices also that here. So that is the depends upon the market requirement. You are designing the product also that's here. That product also consists of the what are the specifications. Specification means also what are the inputs, what are the outputs, what type of the control signals needed for that product also that's here. And also then after that architectural specification. First you can just now I draw the 8-bit comparator also that's here. According that you can draw the architecture specifications. For that specification, how many inputs, how many outputs, and what are the output, how to get the output also that's here. Then functional specification. So how to get the output also that's here. What are the output also like that less than, greater than, equal. So not only that one also we can write also million machines, more machines also. They are the very important here. So controlling signals and also lift floor also. Lift also we are writing the code by using of the Verilog also that's here. So I can press the priority of the lift also that's here. And coming to the here also digital analog IP SoC also that here. So digital analog IP also needed here. So already you discussed about the IPs here. So IP is nothing but intellectual property. It is a not only one component. It is a not only one component, not only one peripherals, because it is interfacing and interconnecting of the digital and analog block also that here. Then also coming to here also next block also that here you have to need the verification also here. So verification is also very important role also here. So what are the writing the program is not important here. So writing the program that also you can verify that also, that is important here also, because we are not verify the program, we are getting the error also. The customers are not satisfied also here. So come after that verification, then go to the next block also, that's logic synthesis and DFT also that's here. So already logic synthesis means also which convert the RTL to netlist, and DFT also, DFT stands for the design for testability also that's here. So then after that also we can test the vectors, and also you can aid by testing by using of the ATPG. ATPG stands for the automatic test pattern generated. And next coming to the timing analysis also that's here. So timing analysis also already we discussed. This is setup time, hold time, metastability. You can know timing, any timing violations, your customers not satisfied also. You are not getting the output within that time. You are not getting the output within that time. That is that will be described by the timing analysis. That is also concerns of STA. The STA engineers also avoiding of the timing violations. So then after that also place and CTS placement. CTS stand for the clock trees in the here also clock synthesis tree also that's here. Clock synthesis tree and routing also that's here. So you have to clock synthesis tree means also you have to reduce the clock and you can avoid in the any metastability by using of the CTS also here. CTS also. And routing means you have to make the connection between the one gate to another gate also that's here. These are the things also. After the STA also that's here. Then after that STA forced layout netlist generation here also. So forced layout means also already here also layout also you need also. Layout in descriptions of the layers also available. So like a metal and polysilicon, and also here also silicon dioxide also here also, and N diffusion, P diffusions, because of transistors also need within the transistor gives the so many layers of that here. Then again the DRC means also design rule checker and layout versus schematic, and also here also these are the needed also here. So here also here DRC any layout will be violations or width of the polysilicon is high or low, then they are going to that also you can tested by the DRC also. So after that also you create the GDSII file. So GDSII file. So then after the creating of this file also we are sending the fabrication also here. So fabric. Okay. So thank you. So today I discuss this topic also. Remaining topic I will discuss later.